For each of these scenarios, we want to state the null and alternative hypotheses with the correct notation or the relevant parameters. So if we're testing to see if the average height of males is different than the average height of females, we would be comparing two groups. And if we're looking at an average and we want to see what we'd expect to see in the population, our test would be looking at if the average height for the two groups is equal, which is the same as saying the difference in the two population means is 0, versus an alternative that there is a difference in their heights because we're asked for different. So we would do not equal to 0. You can equivalently write these as mu1 equal mu2 or as mu1 not equal to mu2. In part B, we're looking at the average height of males as greater than the height of females. And so for this, we need to identify which one we're calling group 1 and group 2. So let's let group 1 represent the males and group 2 represent the females here. So if I am looking at comparing these two, again, I test if the difference is 0, or equivalently if mu1 and mu2 are equal. And now I want to know if the height of the males is greater. So my alternative hypothesis will be that mu1 minus mu2 is greater than 0. That is the same as saying mu1 is greater than 2, and I called group 1 the males. And C, we're testing to see if a particular coin is weighted. We would be looking at a proportion, because when we're looking at a coin, we'd look at heads, tails, and what percentage were each. So if the coin is fair and not weighted, we would expect 50-50 for heads, tails, so a proportion of 0.5. And we're trying to see if it's just not fair, so we would look if it proportion is not equal to 0.5. If we're testing to see if the average rent in La Crosse is less than $850, this is quantitative data, so we'd be dealing with a mean, and we are looking at a single sample here, so rent in La Crosse. So we would want to test if the mean was $850, and what we're really interested in is it less than $850. So our relevant research hypothesis is mu less than $850 with the baseline of equal to in the null. And then we're testing to see if children have a preference for the cereal box with cartoons, as we had discussed as a motivating example in the earlier video. And so if the children had no preference, we said they would be choosing each box with a 50% rate. So the children picking the box with the cartoons would be 50%. If they do have a preference for the cereal box with cartoons, we would expect more of them to be picking the box with cartoons. So if P here is representing the proportion that pick the cartoon box, a preference would be that there was more than 50%.